Hello, scientists. Today we are going to be focusing on Sir Isaac Newton and two of his three laws of physics, laws of motion and how things move. Everybody knows Sir Isaac Newton. He was sitting under a tree, an apple fell on his head, and he became a scientist. Well, not quite. He was already a very, very intelligent, amazing scientist up until that point. What happened is he had amazing curiosity, which I know each and every one of you do too. So an apple fell down off a tree, hit him in the head, and he said, why did that happen? How did that happen? And that simple idea spread all the way to figure out what gravity is, this invisible thing that's always acting on us. So, to get started today, the first law of motion says that an object that's resting stays at rest unless acted on by an outside force. So, it also says that an object in motion will stay in motion unless acted upon by an outside force. So, we have a bike helmet here. Now, it's not moving because Newton's first law says an object at rest will stay at rest. It still hasn't moved. I don't know what to do. It's still not moving. It's just me moving. Nope. Still hasn't moved. Still not moved. This helmet will stay at rest until acted upon by an outside force. Here is your outside force. I can be a force. I moved the helmet. Wow, that all makes so much sense, right? Yeah, way to go, Mr. Burling. You're so smart. Oh, thanks, everybody. What did you say the second part of that was? An object in motion stays in motion. That means it keeps moving unless acted upon by an outside force. But, Mr. Burling, when I throw something, it eventually stops, right? Yes, you are 100% correct. So I want you to think about to yourself. You have something in your hand. You're out at recess. Maybe you're playing catch. Maybe you're shooting a basketball. You push, maybe you kick a soccer ball. You push that object away from your body, whether you're throwing it, kicking it, hitting it if you're playing foursquare, whatever it is. You're pushing that thing away from your body. Eventually it comes to rest, though. What is acting on that object that would stop it? If you thought to yourself, well, maybe it was windy and it knocked it down, that is absolutely an object or a force that would be acting on this object. If you said, well, Mr. Burling, you've been talking about this invisible force, gravity, you are 100% correct. Gravity is pulling that back down towards the ground. And then if you said, well, I kicked the soccer ball and then it was rolling in the grass and the grass slowed it down. Yes, you would be 100% correct because the grass creates friction. And the more friction that we have in a situation, the slower or the faster our object will slow down. So that's why in tall grass, the ball doesn't go very far, but in short grass, the ball will roll farther. One of my simplest examples of showing friction is our carts right here. I have the brake off. The cart moves nice and easy. I'm barely moving this with my one arm. Nice and simple. Now, when I apply the brake to the tire, push it down, now I have to use a lot more effort to move the easel. Why? Because when I push this lever down, I am adding friction to this tire, and it makes it harder to push around.